I'm very pleased to speak today at the event. My topic is re-engineering AI as regenerative commons. Ladies and gentlemen, artificial intelligence is often presented as a clean technology that turns data into insight. We picture elegant and invisible algorithms. But the reality is much heavier. Training and running large AI models requires vast amount of electricity and water. Hyperscale data centers already account for a noticeable share of electricity demand in several countries, and the AI boom is expected to push this sharply higher. Many new facilities are being built in regions that are already short of water, putting them in direct tension with households, farming, and local ecosystems. So when we talk about AI, we are not just talking about software. We are talking about concrete, steel, power lines, and pipelines. We are talking about land, water, and communities. The story starts even earlier than the data center. The AI stack begins in mines and refineries, lithium from South American salt flats, cobalt from Congolese pits, rare earths from heavily polluted sites in Asia. At the end of the chain, rapid hardware turnover and e-waste leave their own scars. And there is another layer, the largely invisible workforce that makes AI intelligent. Millions of people, often in Kenya, the Philippines, India, and other countries in the global south, label data, moderate content, and train models. They perform stressful, low-paid digital piecework so that AI systems appear effortless and automatic to the rest of us. Seen this way, AI today behaves less like a neutral innovation and more like an extractive industry. It draws on minerals, energy, water, data, and labor. And the benefits and burdens are distributed very unevenly. In that context, responsible AI toolkits and ethics statements, while useful, are simply too small a frame. They are finishing coat of paint on a structure whose foundation we still have not designed properly. This matters directly for supply chains. In logistics, we have already learned that linear take, make, dispose models are colliding with physical and regulatory limits. We see it in resource constraints, in climate-related disruptions, in extended producer responsibility, and in mounting social expectations. Circular economy and regenerative approaches, the famous R's, repair, reuse, recycling, ecosystem restoration, are moving from the margins towards the center. AI is often presented as the key enabler. Machine learning to optimize reverse logistics, manage product passports, and track environmental performance along complex value chains. That promise is real. AI can help us to design closed loops, reduce water, and improve transparency. But here is the paradox. If the AI that orchestrates circular supply chain is itself built on extractive practices, we effectively use a depleting infrastructure to manage regeneration. No amount of branding can resolve that contradiction. Leadership that simply bolts a reasonable AI label onto a responsible AI label onto an extractive stack will not be enough. We need to redesign the stack itself. So, what are the alternatives? A more adequate response is to treat AI as a socio-technical common that must be governed for regeneration, not just for speed and efficiency. That means asking 3 questions. How do we count AI's real footprint? How do we share control along the chains? And how do we make regeneration the brief, not the byproduct? Let me take each in a turn. First, count AI's real footprint. Work on AI, climate, and justice reminds us that we cannot just focus on model accuracy and cost savings. We must also ask who bears the environmental and social costs, and who makes the decisions. Boards and policymakers should treat the siting and design of AI infrastructure, including data centers, networks, and hardware, not as a narrow technical choice, but as a question of land use, water allocation, grid stability, and local consent. In supply chain language, the control towers of the future should not build on unsustainable draws from the very ecosystem they are supposed to help safeguard. If the nerve centers of our digital logistics rest on fragile water tables and overstretched grids, we are simply shifting risk from physical assets to digital ones, not reducing it. Counting the real footprint of AI makes it visible in the same way we now make Scope 3 emissions visible in our chains. And we know how difficult that is. What we measure, only what we measure, we can govern. Second, share control along the chains. Analysis of what some call AI colonialism show how resource extraction, data harvesting, and outsourced digital work can deepen existing inequalities, especially in the global south, while the narrative of progress remains concentrated in the global north. This has very practical implications for companies. If your AI strategy is tied to sourcing, manufacturing, and distribution, it should include mechanisms that share value and decision rights. I have 3 points in mind. Long-term investment in local skills and infrastructure where we collect data and build capacity. Fair contracts and protections for data workers who support AI models. And joint oversight of key data platforms with partners in supplier countries through multi-stakeholder boards, data trust models, and other shared governance arrangements. This is the digital equivalent of moving from single-sourced components to shared strategic stockpiles. It may be slower to negotiate, but it builds resilience rather than dependency. And in a world of cascading shocks, resilience is the new efficiency. Third, make regeneration the brief, not the byproduct. Today, most AI projects in supply chain are framed around incremental gains. Cut a bit more waste, shave a bit more of transport cost, push inventory a bit lower. All that matters, but it is not enough. We can set a higher bar. AI already helps companies to reduce waste, optimize routings, and monitor carbon and compliance. The next step is to apply the same analytical power to regenerate soils, waterways, and communities. Again, 3 points. Configure procurement algorithms to favor regenerative agriculture, not just the lowest price. Use AI-driven insights to stretch the life of materials, not just to accelerate throughput. Direct investment towards reducing physical climate risk for the most exposed partners in the chain, rather than simply rerouting around them. In this model, AI becomes part of a regenerative loop, informed by ecological limits governed by shared institutions and measured against long-term resilience rather than quarterly throughput alone. Left to current incentives, AI is likely to follow the familiar path of previous general-purpose technologies, which means rapid deployment, concentration of control, diffuse environmental damage, and only partial correction after the fact. We still have time to choose a different path. We have decades of learning from supply chains, from circular economy practice, and from climate science. We can apply that learning to AI itself, to the data centers, the hardware, the contracts, the matrix, and the people. If leadership fails to act, the algorithms optimizing our factories, ports, and warehouses will rest on foundations that undermine the very system they are expected to improve and secure. If leadership succeeds, AI can evolve from a hidden extractor of planetary and human resources into a shared infrastructure that helps repair them. The real choice is starker than it appears. Continue to treat AI as a new kind of mine, or re-engineer it as a generative commons. Thank you.